what's weird is I normally like to stand, but I feel like I should not overexert myself after the COVID shot. Okay, so if we look at this particular section is about taking the derivative implicitly. So we have to talk a little bit about explicit versus implicit. Explicit, with an E, is anything that looks like this. 3x squared minus 5. What makes it explicit is the fact that y is by itself. And not just by itself, but it is by itself to the first power and of a coefficient of 1. So that means the number in front of y is 1, and it has an exponent of 1. Okay? That is an explicit form. Everything that you guys have dealt with so far with derivatives have been in explicit form. Okay? I was able to get y by itself. Y was to the first power, had no exponent listed, no coefficient. Okay? Now, there is implicit form. So this was explicit. Y equals 3x squared minus 5. And I'm going to get rid of this part because we're not going to talk about the derivative yet. And when we take this derivative for explicit, we get y prime is equal to 6x. Okay? And I keep referring to, like, the idea of when you're in elementary school, you're like, oh, let's all add. And then it's like, oh, let's find the sum. And you're like, well, what's the sum, right? And then you're like, well, why does it change names? We're about to change names again. Okay, so, and it's just like the idea of, like, you know, the difference of writing the equation as y equals and the difference with saying that it's an f of x equation. An f of x equation tells you a little bit more about the function. It tells you that it is a function, it passes the vertical line test, and so there's some specific properties that go along with the fact that it's f of x versus y. Now, in this case, what I'm going to do is I'm going to change the notation for the derivative. And the notation that I'm going to use is dy over dx. We'll zoom in a little bit. And this notation itself means to take the derivative of y with respect to x. What it means is that it gives you a little bit more information. It tells you that y is the dependent variable and x is the independent variable. And it is specifically used even though it can be used in almost every situation, it is more specifically used for implicit situations. Implicit situations are situations where you cannot isolate y by itself to the first power and a coefficient of 1. So an implicit situation would be like y cubed plus 3y squared plus 2 is equal to x. That would be an implicit situation. X squared y plus 3x plus y cubed equals 7. That's another implicit situation. I cannot get y by itself to an exponent of 1 and a coefficient of 1. Yes, William?
So are there multiple implicit forms of the same equation?
Yes. And so those are your implicit, types of situations. And you have to be able to take the derivative of an implicit form. And that's the goal, is to take the derivative of an implicit form, not just to do one for explicit forms. So when you do the derivative of a implicit form, there's some rules. Now I could have change the color for a second. I can take the derivative of this y equation implicitly, even though it is an explicit form. Anytime I take the derivative of y, the derivative of x is just 1, so the derivative of y is 1. But anytime I take the derivative of y, I have to write dy dx being multiplied by it. When I take the derivative of x, I have the derivative of x squared, or 3x squared, which is 6x. Technically, if I did this implicitly, I would write this as dx over dx, meaning I took the derivative of x with respect to itself. We never write this ever because dx over dx is 1. So all we do is we just take the derivative of y and call it dy dx, and we say it still follows the same pattern of it being 6x. Okay. Now what you're going to find is, once you guys start to see the process, because it is, for all of my flashcard people, seriously, like this is like, I'm going to write out the steps, I'm going to follow the steps every single time, and every single time it is going to work. Anything is easier after you've done chain rule. Anything is easier after you've done the Google Forms for chain rule. I just say, so what you're going to find is you're going to be like, this section's not that bad. Okay, so let's be clear. This section is easy compared to chain rule. What you're going to find, though, is that the hardest part about this is that it takes too much time. So if you're a little OCD like me, you're going to have a hard time on a test cutting your losses and saying, you know what? This is going to take too much time to do. I have to go and see if I can do another question faster. When you take a quiz or a test in this class and also on your actual AP test, you want to answer questions quickly and accurately first. The ones that you can answer as fast as you possibly can and accurate as possible, as accurate as you can possibly be, those are the questions you want to answer first. After you've gone through the whole test and only done the quick and accurate ones, right? Then you go back and do the ones that are slow and accurate. It's going to take you a long time or longer than 2 minutes, but you're pretty sure that if you finished it, you're going to get it right. You do those second. This would fall into that category, slow and accurate. More than likely, you're probably going to get the right answer. It's going to take you forever to get there. Some problems are quicker than others, but more often than not, this is going to take you more than 2 minutes to do. So this falls into the slow, accurate situation. What falls into an everything else situation, more than likely, is some chain rule questions. Those are like, I have no idea where to start, and I am more than likely not going to be accurate. Yeah, like more likely not going to be accurate, and it's going to take me too long to try to figure out what to do. Those questions you answer last, and you do what Ethan is mimicking right now, which is making me laugh. But yeah, you totally just drop the pencil and try to see which one you're going to choose. Now, here's the thing. Random number generators digitally are not really random. They're always created by some sort of algorithm. So what I would do when I was taking a multiple choice test is I would look to see what answer I've chosen the most, and I would pick that letter for everything I was going to guess on. You always want to pick one letter. You don't want to switch letters around. You want to pick one letter and guess that same letter all the way through. I would strongly suggest it not being E. Don't let it be letter E that you do that with. But other than that, pick a letter and just stick with it. Yeah, or I always like to choose the one that I've already answered the most 4. So I always try to look at that. I will tell you that because of the way I do everything in Edulastic, the only thing I try not to do is to throw you guys off with the lettering. And so if I were to throw you off, it was not on purpose. It was literally because I started to write questions and then I stopped and forgot what I was doing. So I wasn't paying attention to the letter choices for the answers. I try not to like make you wonder like, why are there 5 E's in a row? Yeah, I try not to do that to you. I used to back in the day. I know. Well, I worry about that because I know that what you guys start to do is you start to think, oh my god, I've answered the letter A too many times. You know, and I don't want that to be the reason why you miss questions is because you thought that there was a weird pattern that shouldn't have been there that really actually is there, but it's there because it was an accident. So I try to be very conscientious about that so that your mind doesn't play tricks on you. But I just want you guys to know, like, as far as your quiz and your test, your actual AP test, that's kind of what you're looking at as far as how you would want to structure answering questions on a multiple guess part. Okay, so there's some rules or some steps to solve implicit functions. Okay, it's 4 steps. It is the same 4 steps every single time. But I have to be clear about something. When you take the derivative, and this is going to come up because you're going to look at question 2 and you're going to do question 2 incorrectly, which has been like the entire day. So it's just okay. I knew it was going to happen because I'll say this right now and it's still going to happen. Anytime you have the product of 2 variables, you have to use product rule. Don't do weird stuff. Don't break math. You have to use product rule. So if I had this situation, or even if I had a coefficient here, I would group the coefficient with one of the variables and then leave the other variable off to the side. Product rule exists every single time you have 2 terms where you have variables involved and they're being multiplied together. This is the most commonly missed thing ever. That and forgetting that the derivative of a number is 0. Yes. I'll say it. You still do it. It's okay. You'll forget. Okay, so to take the derivative implicitly, step 1 is to differentiate both sides with respect to x. What that means is every time you take the derivative of y, and only when you take the derivative of y. Not when you take the derivative of x and there happens to be a y that tags along. No, every time you only take the derivative of y. I'll say it again, you'll still miss it, it's okay. Every time you take the derivative of y, you have to multiply by dy dx. So dy dx gets multiplied every single time you take the derivative of y. Okay?
Now what you mean by this is take the derivative of y and then separately multiply both sides by it.
No. You'll see. Your step 2 is to move all the terms that have dy dx involved to the left-hand side of the equation and move everybody else to the right. Step 3 is to factor, and step 4 is to isolate dy dx. 4 steps every single time. Okay? So let's look at one. Okay. What's the derivative of y cubed? 3y squared. And then to answer William's question, this y squared gets multiplied by dy dx. I took the derivative of y, so I have to multiply by dy dx. Now, take the derivative of y squared. 2y dy dx. Take the derivative of negative 5y. negative 5 dy dx. Take the derivative of negative x squared and you get negative 2x times nobody. Okay. Then take the derivative of negative 4 and you get 0. Okay. So, step 1, done. Step 2, move everybody that doesn't have a dy dx to the right-hand side and move dy dx to the left. Well, dy dx is already on the left-hand side. So all I need to do is I just need to move the 2x to the right. And step 2 is done. Step 3 is to factor out dy dx. So 3y squared plus 2y minus 5 is equal to 2x. Step 3, done. Step 4, get dy dx by itself. Don't break math. Dy dx is being multiplied, not added. Don't start subtracting on me. You laugh. It happens all the time. You know, I'm just saying, don't break math. Okay. Okay, so divide both sides by your 3y squared plus 2y minus 5. And that's it. No. Not unless you want to take a second derivative. No. Oh, but don't wait. Just wait. We're going to do that next. No. All right. Are we okay-ish? Are we okay about math? I should specify. This will take, depending on the question, it could take more than 2 minutes to do it. Sometimes you guys can be really quick. It depends on how involved the implicit is. If it's like the next one we're about to do, it's not going to be a 2-minute question. This one, I think you could probably do pretty close to 2 minutes. You could probably push it and get it done in 2 minutes. Others, I don't know if you could. Especially if it looks like question number 2 on your homework, where you have a product rule, or if I throw in sine and cosine, you're kind of screwed. So. Oh yeah, no. Number 2, number 2 on the nose is about to be bad. Really? Oh yeah, just wait. First of all, before we get that far, anybody have a question about the first one? Alright. You ready to hate algebra? More so than you already do. Okay, so here's the thing. Let's be clear. I can do this explicitly. If I really wanted to, I could do this explicitly. I can get y by itself where it has a coefficient of 1 and an exponent of 1. I could. It would take a lot of work to do a second derivative that way because you would have to do chain rule. I like to try to avoid chain rule in my life if I can help it. So at the end of the day, I would do this implicitly.
Couldn't you just, before you take the derivative, reorder?
That's what I'm saying. I could have reordered it if I really wanted to, but that requires me to have chain rule in my life. Because when you square root both sides of the equation, you're going to end up with chain rule. So you're going to end up with a 25 minus x squared, and you're going to be square rooting that. So you're going to have an inside function of a 25 minus x squared and an outside function of square root. Which I'm telling you right now, like I like to avoid chain rule if I can help it.
I thought you could end up with super simple y is equal to x plus 5.
The easiest thing to do is to do it implicitly. So take your derivative of x squared and you get 2x. Take the derivative of y squared and you get 2y dy dx. Take the derivative of 25 and you get 0. So 2y dy dx is equal to negative 2x I'm writing small for a reason. So dy dx is equal to negative 2x over 2y. So dy dx is equal to negative x over y. Okay, there's your first derivative. But Ethan's favorite, we're going to do quotient rule. Yeah, it was going to happen regardless. So, and it's about to get worse than just that. Because I have to show you what College Board would do on a multiple choice, because they would do this on a multiple choice. They would do this on a multiple choice. And the bad part about it is that the answer we're about to get is one that you'd say, yeah, there's no way that that's the answer. That's the bad part. So don't ever discount answers until you start to try to solve stuff. Unless you're really just dropping the pencil and trying to see what letter you're going to choose. Okay, so we're going to do quotient rule. So let's be clear. I can show you at some point if you really are curious, or you can just memorize it. D squared y over dx squared is the notation for the second derivative. That whole thing means the second derivative. It is a squared in between the dy, the d and the y, and it is a squared outside of the x. It's actually mathematical, unfortunately. Okay. Let's do some quotient rule. Denominator times the derivative of the numerator. So the derivative of negative x is negative 1 minus a negative x times the derivative of y, which is 1 dy dx, all divided by y squared. Okay, you cannot leave it like this. Not even on a free response test can you leave it like this. Because dy dx represents something. So you have to plug in negative x over y in for your dy dx. So d squared y over dx squared is equal to negative y plus x times what dy dx is, which is negative x over y, all divided by y squared. Okay? Now, if this was a free response test, you'd be able to leave it like this and nobody actually cares. We're going to solve this as if this was a multiple choice question. Okay. So, I'm like, are you ready for it? So d squared y over dx squared. So you have negative y minus x squared over y all over y squared. Technically, that y is over 1. So in my numerator here, I can find a common denominator. So d squared y over dx squared. You're like, I knew it. Negative y squared over y minus x squared over y all over y squared. You're like, I feel you. All I did is I found a common denominator in my orange. I multiply my first fraction by y over y. Yes, Ryan.
For like the negative x times dy dx, how's that work?
Oh, this is over 1. This?
Like the negative x times the dy over dx on the first part of the second derivative. How does that work?
This part?
Yeah. Oh.
How do I multiply these together?
The negative x dy. It just equals what?
Okay. I was like, hold on, I could change all the colors. Now everything in orange is equal. I'm like, wait, there was something else that was orange.
I just didn't see that you closed that.
Oh, okay. Okay, so now what I want to do, d squared y over dx squared, negative y squared minus x squared over y squared. Okay. The y squared at the bottom is over 1. So I can invert and multiply. D squared y over dx squared negative y squared minus x squared over y times 1 over y squared. Yep, d squared y over dx squared. It's about to still get worse. Negative y squared minus x squared over y cubed. There's still more you can do. In your numerator, you have a common negative 1. So I can factor out a negative 1. And then x squared plus y squared is what? Is 25. And that is the answer. I told you it was bad. I told you algebra was about to get bad. So College Board likes to do stuff like this. You wanna know what makes this even more terrible than anything? That's a good question. So Ethan's got a very good question, and that is, how would I know that I had a problem and I needed to do it? Okay. So let's be clear, because this is how you guys think. And it's human nature. So I would think the same exact ways. I'm not faulting you for it. You take your multiple choice test, right, and you start to go through it, and you're like, oh my god. So then you're like, oh, you're hoping that this answer's there, it's not there. Then you're hoping that this answer's there, and it's not there, right? So you start to look at all your choices, right? Then what you realize is you say, oh, well, I've got something that looks like this, right? And what College Board has is it has an answer kind of like it, but it's missing the negative there. So what do? You're going to choose that one and think that you messed up somewhere, right? Or they would have done something, and what's even worse is they would have done something where they would have left the yellow one but gotten rid of this green one here and made that a plus. And then when you see two answers that kind of look very similar, but one of them's off by a negative, you're like, it's got to be one of these two. I must have made a mistake somewhere. It's got to be one of these two. What you're not realizing is that will be like that answer, the right one, will be a singleton answer. And there'll be all the other four choices will be a variation of the one that's in blue. Just to throw you off. So I do this question specifically every year to illustrate for you guys. Don't be quick to think that you made an error. Don't be so quick to think that you screwed up. Try to think about, is there something more I can do to try to continue to get an answer that's there? So I do this question every single time because College Board does stuff like this. And some college professors do it too. You know, so it's really important that you guys can see that this is what's going to happen when you take a test, because knowing is like half the battle. Seriously, like knowing that this can happen to you just means that, okay, before I go and choose something that's in blue, what I'm going to do is I'm going to make sure, I'm going to just double check my positives and negatives real quick. Then when you realize that you're probably pretty confident on what it is, then you got to think that there's something more. There's something that you're not seeing. Okay. So, and that is the reason why I do that particular question. Yeah. So I'm just questions that you guys have. We'll do the inverse function one tomorrow. Because it's gone like, the first period they were like, oh my god, and then I was like, yeah, I'm not doing the inverse function question today. We've hit our quota for your brain capacity for today. We'll wait till tomorrow.
Speaking of that, I was just kind of like reading a note saying, when does therapy start?
I know, right?